See, today we will discuss about the physical properties of matter. In physical properties, there are some related terms: mass and weight. Another is length, volume, density, temperature. As we know, mass is the inherent property of matter. Initially, I have told you what is matter. Matter is those who occupy places and which has mass. So mass is inherent property of matter. Actually, in physics, what you have studied: inertial mass, gravitational mass. Due to mass, any object have two property. One is inertia, another is gravitation. So mass is inherent property. If a matter is there, a property will exist with the matter. That is mass. Mass is inherent property of matter, which doesn't change place to place. Its unit is kg. ठीक है, तो एक मास जो है फिजिकल प्रॉपर्टी है मैटर का, जो हमेशा एग्जिस्ट करेगा. मैटर है तो 100% वहां पर मास होगा ही. ठीक है. दूसरा हम क्या करते हैं बेटा, वेट. वेट मीन क्या होता है? mg. यू नो द फोर्स बाय विच अर्थ अट्रैक्टेड, अर्थ ड्रॉन ए मैटर टुवर्ड्स इटसेल्फ, या द फोर्स exerted by earth is known as weight. Actually, weight depends upon gravitational acceleration. Weight can be changed place to place, but mass will not change. Mass is inherent property of matter. See here, what is volume? I have told you that a matter has mass and it occupies space. The space occupied by matter is known as volume. Length, here also physical property. Length is a bond length, the distance between the molecules. So this we have to calculate for physical property as for matter. So this is length. Density, mass per unit volume, also a physical property. Density more if a small volume they have greater mass. We can also see solid to liquid, density will change. One also physical property you have to study: density. Temperature, degree of hotness, how much hotness will be there, and also you know temperature Celsius, Fahrenheit, Reaumur scale, Kelvin scale. So these are the physical property related to matter. Okay, see here laws of chemical combination. In laws of chemical combination, first we will study about the law of conservation of mass. What is law of conservation of mass? This states that during a chemical combination, total mass of reactant is equal to total mass of product. Mean you can say during a chemical combination, mass neither can created nor destroy. For example, suppose I have taken a chemical combination H2 plus O2 is equal to H2O. If you will see here, suppose I have taken 4 gram of hydrogen I have taken, and 32 gram of oxygen. If I am combining, then what we have obtained, when water we have obtained that calculated mass, so that will come 36 gram. So here we can say the total mass of reactant is equal to total mass of product. Mass neither can created nor destroyed. One thing more I want to tell you, this is in chemical reaction, mass is conserved. But when we will talk about the nuclear reaction, okay, so their mass is not conserved. Their total mass of product is less than total mass of reactant. There is mass defect, it is called, and that mass convert in the form of energy. E is equal to del m into c square. ठीक है. तो न्यूक्लियर रिएक्शन में मास कंजर्व नहीं रहता. मास ही किसमें कन्वर्ट होता है बेटा? एनर्जी में. न्यूक्लियर रिएक्शन मतलब जैसे फॉर एग्जांपल आप यूरेनियम बम्बार्डेड विद न्यूट्रॉन, ठीक है, वहाँ बेरियम, क्रिप्टॉन एंड 3 तो लॉस ऑफ ए लॉट ऑफ एनर्जी वी आर फाइंडिंग. तो दैट लॉट ऑफ एनर्जी इज ड्यू टू मास डिफेक्ट. ठीक है. तो आइंस्टीन ने एक इक्वेशन भी दिया था, E इज इक्वल टू mc स्क्वायर. एक्चुअल में m इज देयर मास डिफेक्ट. तो मास डिफेक्ट इज द change of mass during the nuclear reaction, but in chemical combination mass neither can created nor destroy. Laws of definite composition are proportion. This law states that any pure compound always contains same element in the definite composition or proportion by weight, irrespective of the method of preparation. See here, what is this law say? Law of definite proportion. नाम से क्लियर है. Definite proportion कहते हैं for any pure compound. Suppose I have taken one compound H2O. In this compound, two elements is there, hydrogen and oxygen. So in this hydrogen and oxygen, if we'll see by weight, whatever the process of making H2O, they are always in which ratio? 1:8 by weight. By weight always. हम देखेंगे इनका जो रेशियो होता है कितना होता है बेटा. If 1 gram hydrogen we have taken, तो oxygen should have 8 gram. ठीक है, always. ठीक है, whatever the process to making of H2O. So this is the law of definite composition. One more example, if I am taking NH3. If we'll make ammonia, if we'll see the ratio of nitrogen and hydrogen by weight, it always come. If you have taken 3 gram of hydrogen, ammonia will be 14 gram. So always, if we'll take the ratio, if we'll see the ratio, whatever process of method of preparation of ammonia, always by weight, if we'll see the ratio of nitrogen and hydrogen, they are always come 14:3. So this is the law of definite proportion. Law of multiple proportion. This law states that when two elements chemically combine to form two or more compounds with different composition by weight, then masses of one element that combine with a fixed mass of other element are in the ratio of small whole numbers. What they are saying is, suppose two elements, suppose I have taken hydrogen and oxygen. If they are forming more than two compounds, suppose they have formed, one is H2O, another they have formed, this is water, hydrogen oxide, hydrogen peroxide. Two different compounds they have formed. If you see here, the 2 gram of hydrogen mixed with 16 gram hydrogen and oxygen, if you see, in this 2 gram 16 gram of oxygen, here 2 gram of oxygen, it will take 32 gram. If hydrogen you have fixed, then the ratio of oxygen by weight, so they are in simplest ratio. The ratio of oxygen for fixed hydrogen, 16:32. This is fixed, this is 1 ratio. This is the simplest ratio, are small whole numbers. One more example we can take. Suppose we have taken two compounds, nitrogen and oxygen. Two elements I have taken. So different they are forming nitrogen oxide, nitrogen peroxide, N2O5. Different compounds they are forming. If we see the ratio, nitrogen and oxygen in all this, here what you will see, nitrogen 14, oxygen 16, here 14, they are 32, here 28, this is 80. If we will take the nitrogen same, divide by 2, what happened? This becomes 14, this becomes 40. So we will see the ratio of oxygen. Ratio of oxygen for fixed nitrogen 14, 14, 14. What will be the ratio? 16 ratio 32 ratio 40. So you can see here 1, 2, divide by 8. What will be the simplest ratio? 2, 4 and 5. So this will be the simplest ratio or small whole numbers. So this is the laws of multiple proportion. If you have taken two elements, they are forming two or more compounds. If we have taken mass of one element constant, then other element have a constant multiple ratio small whole numbers. Gay-Lussac's law of gaseous volume. This law states that when gases combined are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. Gay-Lussac law, what they have said, if gases are combining and the reactant are gases and product is also gases, they will see at constant pressure and temperature or same pressure and temperature or at NTP, normal temperature and pressure, if we will say all gases are in the simple ratio. For example, suppose I have taken H2 plus O2, they are forming 2H2O. If you will see, you have taken a same temperature and pressure, so you will see two volume of hydrogen is there. So one volume will be the oxygen, two volume will be the water. Steam. All are in gaseous state. You will see two volume will be hydrogen, so there will be one volume of oxygen, then two volume of steam will form or water will form. Same way, other example, so there is ratio what? 2 ratio 1 ratio 2. If we'll see one more example, if nitrogen combined with hydrogen, they will form ammonia. If we'll see here, at the same temperature and pressure, if we'll see the volume of nitrogen, hydrogen and ammonia, they will see 1 liter if nitrogen is there, 3 liter hydrogen you have taken, then 100% there will be 2 liter of ammonia. Mean by volume they have a simple ratio. What are the ratio? 1 ratio 3 ratio 2. So there is the simplest ratio in nitrogen, hydrogen and ammonia, 1, 3, 2. This is the Gay-Lussac law of gaseous volume. Avogadro's law. It states that equal volume of different gases under identical condition of pressure and temperature contain equal number of volume. ये बहुत important है Avogadro's law. ये कहता है कि if you have taken a pressure and volume, pressure and temperature, identical condition, pressure and temperature you have taken. If you have taken different gases, so equal volume contains equal number of molecules. See here you will see after that, if we will take the STP, standard temperature and pressure. What is standard temperature pressure? 0 centigrade temperature and 1 atm pressure you have taken. So different gases, if suppose you have taken hydrogen, you have taken nitrogen, you have taken ammonia, so all gases if you will take, you will see that each gas 22.4 liter of gas contains how many molecules? 6.02213667 into 10 raised to 23 molecules. दिस इज ऑल्सो वी विल नो एज द एवोगैड्रो नंबर। तो ये बहुत इंपॉर्टेंट है कि अगर हमने क्या किया बेटा, एनटीपी लिया, ठीक है, एसटीपी लिया, स्टैंडर्ड टेम्परेचर एंड प्रेशर, तो उसमें यू विल सी कि अगर तुमने क्या लिया बेटा, इक्वल वॉल्यूम ऑफ डिफरेंट डिफरेंट गैसेस, जैसे सपोज किया तुमने 1 लीटर ले लिया, 1 लीटर अमोनिया, 1 लीटर नाइट्रोजन, 1 लीटर हाइड्रोजन, 1 लीटर ऑक्सीजन, तो फिर काउंट द नंबर ऑफ मॉलिक्यूल्स, तो ऑल हैव सेम नंबर ऑफ मॉलिक्यूल्स, सभी के नंबर ऑफ मॉलिक्यूल्स क्या होंगे, सेम होंगे। दिस इज कॉल्ड अवोगाड्रोस लॉ।